Hello, Algebra 2 Honors students. Strange intro to a video, but that was one of my favorite punk rock groups growing up called Bad Religion. And they mention logarithms, believe it or not, in a song of theirs called When from 1988. So I figured I would start this video with some punk rock. Anyway, happy second semester. That was 30 years ago, 88? Wow, I was 5. Anyway, all right, purpose of this video is, first of all, that you understand what a logarithm is, because at this point, all you know about logarithms really is that they are inverses of exponential functions. So you have some idea what their graph looks like. You have some idea that they kind of undo exponents. But we're going to look at them as their own function now. So you have to understand what a logarithmic function really is, how to evaluate a logarithmic function, how to solve a logarithmic equation, and also how to simplify with logarithmic expressions. All right, so we'll get into the properties of logarithms later on. Purpose of this video, though, is really just to understand what a logarithm is and how to evaluate and solve. All right, so first of all, a logarithmic function, like say f of x, equals log base 2 of x. That is what some might say is the most, the parent logarithmic function. That is derived from it being the inverse of the exponential function y equals 2 to the power x. Okay, so just to remind you, if you were given this function, say function g of x was 2 to the x power, then if you were asked to evaluate, say, evaluate g of 8, then think about what that would be asking you to do. I know you plug in 8 for x, right? So we get 2 to the power 8, and as you know, that means 2 to the power 8 equals what number, right? So 2 times itself 8 times is 512. No. Wow. 256. 2 to the 9th is 512, right? So just to remind you, this is an easy one, but all it's asking you to do is really evaluate what is 2 to the power 8, all right? But if you have the function f of x equals log base 2 of x, that's kind of the inverse of that, right? So if you were given here to evaluate, if you were instructed to evaluate f of 8, what's important is that you understand what that means. That's the whole purpose of my giving this little intro, all right? So log base 2 of 8, think about what that means, all right? You could consider like the table of values for this one and then just find out, the answer that way, kind of by flipping x and y, right? But it's more important that you understand what this means as its own entity. What is log base 2 of 8 asking you to do? All right? Whereas here, 2 to the 8th power means 2 to the 8th equals what? This is the inverse. This means 2 to what power equals 8. All right? So now you're kind of given the answer. You're asked to find the exponent. All right? Instead of giving you the exponent and asking you for the answer, it's vice versa. It's rearranged because they're inverses. All right? So most importantly from this, focus on this expression right here. We read this as log base 2 of 8, as you know, and the answer would be 3, right? You're wondering 2 to what power equals 8. So this answer is plain old 3, all right? So hopefully you understand what it means to evaluate a logarithm. It really just means you're looking for the exponent, okay, in every case. So let's do another one. Let's see. Let me kind of just erase this one. We can use a different base of a logarithm too. It's not just with base 2. So let's do that. Let's say we have a function k of x equals log base, say 4 of x. And say I asked you to evaluate a few problems. Let's say we did, first of all, let's just do an easier one. Let's say k of 64. All right, so this would mean we would be, as always, just replacing the x with the 64. And think about what this means. Log base 4 of 64. That doesn't mean 4 to the 64th power equals what? That's the exponential. The logarithmic expression here means 4 to what power equals 64. All right? You don't have to show any work for this. If you did want to show work, you could write yourself an equation. Think about it. This means 4 to what power is 64. That question, to what power, is your variable. So in this case, an equation that would represent this is like 4 to the, you're looking for this power. 4 to what power equals 64? So we can introduce a variable, say, call it whatever you want. Call it like a. This is really what you're solving. You're finding out the power of 4 that gives you 64. All right? So, you could do it this way, but I don't expect you guys to need to do that for this kind of problem because you know your powers. So the answer is just 3 again, right? 4 to the third power is 64. We can do one that's a little bit more challenging. What about k of, well, let's do 8 again. Log base 4 of 8. In this case, it's not as obvious, right? 4 to what power is 8? Well, it's not going to be a whole number, all right? And by the way, this part of the unit, we're not using calculators, okay? So you have to show you can do this by hand. What power of 4 gives you 8? Probably you don't want to do that in your head, so write yourself an equation here. What power of 4, call it 4 to the a, or 4, I wouldn't necessarily use x because 8 really is your x here. So introduce a new variable. And think about in the past how we've solved that kind of an exponential equation, right? We've used a common base on both sides. So we have 2 to the second to the a power becomes 2 to the 2a equals 2 to the third. And then we set the exponents equal. So we get 2a equals 3. So then a equals 3 over 2. All right, so now we go back up here. We kind of wrote this, we introduced a variable to help us evaluate this expression, but there's not really the variable a. So we kind of might want to show this off to the side on our paper, but the answer you want to include here is just 3 over 2. If we're evaluating log base 4 of 8, the answer is 3 over 2. And that, if you want to check your work, that should mean that 4 to the power 3 over 2 equals 8. But 4 to the 3 over 2 equals 8. And if you played around with that, you would see that, yes, they are equivalent expressions. All right? Just do one more evaluate before we get into a solving problem. What about a problem like this? K of, say, negative 16. Log base 4 of negative 16. All right, think about what that one would be, right? This would mean 4 to what power equals negative 16, okay? Now remember that exponential and logarithmic graphs are asymptotic in nature, right? If you kind of remember the general shape of a logarithmic graph is like this, right? The y-axis is an asymptote. So this function, in this case y equals log base 4 of x, if it looks something like this, remember the domain here, the domain is only positive numbers, right? The domain is that x has to be greater than 0, or we can use the interval with parentheses 0 to infinity, right? Keep that in mind here. Here, the argument, this expression here is called the argument. The argument here is negative, right? Well, that wouldn't make sense, okay? We can't raise 4 to some power to get a negative number, all right? Think about it. 4 to the negative second might be your first thought, but 4 to the negative second would be 1 over 4 to the second, 1/16th, not negative 16, okay? X is never 0, x is never negative in a logarithmic function like this, okay? So negative 16 is not in the domain here. So, if that's the case, the answer is does not exist. This expression does not exist. So we would write DNE, okay? And that does come back to the fact that we have a restriction in the domain with logarithms. So I'll talk a lot more about this kind of problem in class, but don't second guess yourself. The only kinds of bases we're using in this unit are going to be positive bases, okay? So if your argument is negative, or 0 for that matter, that expression's never going to exist, okay? You can't raise a positive number to any power to get a negative, or to get 0 for that matter, all right? We're 9 minutes in, so let's just do one more problem. Let's not even deal with solving equations in this video. This took a little bit longer than I thought. That's all right. Probably shouldn't have wasted time for the punk rock to begin, but that was like 10 seconds, so not a big deal. All right, one more problem. Let's evaluate an expression, not dealing with the function necessarily, but just evaluating, using the concept of what a logarithm is to evaluate this. Let's say log base 2 of 8 times log base 8 of 16. If you were asked just to evaluate that expression, you really want to figure out what each of these two logarithms simplifies to. Like this really is just a really friendly answer. This is just the number 3, right? You're wondering what power of 2 gives you 8. It's just 3. This might be a little more work, But if you solve a simple exponential equation, you then can figure out what this logarithm is. And then you can multiply the two because that's what the problem states. These kinds of problems, you might have addition, you might have multiplication, division. Whatever the problem asks you to do, you have to just do. But evaluating these on their own is really the first step here. So log base 2 of 8, that's kind of obvious, it's 3. This one, it's 4/3. And the reason why that is, I mean, how I figured that out is, you're really wondering, you know, for this guy, kind of make a little thought bubble up here, right? What power of 8, say 8 to the a, or 8 to the, call it c this time, 8 to the c equals 16. 8 and 16 are both powers of 2. So we have 2 to the 3rd to the c equals 2 to the 4th. So then 3c equals 4, and c equals 4/3. Now again, solving that equation is not something you have to do, but if you can't evaluate a logarithm in your head, it's always a good idea to kind of write some work for yourself on the side, all right, to figure out what power of 8 gives you 16. All right? So that's all this is asking you to do. Give me the power of 8 that equals 16. There's no variable, but you might want to introduce a variable to help you figure out what that exponent is. 3 times 4/3, 3 divided by 3 first, they cancel, you get 1. 1 times 4 is 4. So your final answer to this problem is 4. So this is very abstract, right? There's no application of it yet. I'm just kind of getting you used to the notation and to generally working with what a logarithm is. All right? Have a good day.